Hello there. Here are Sir Isaac Newton's law about motion. Now let's go to the motion. Okay. Newton's first law of motion, that an object that rests tends to stay at rest, while an object in motion tends to stay in motion, unless an external force acts upon it. When a basketball player shoots, it would seem that there is nothing to obstruct the ball. Although there are several external forces acting upon the ball, if these forces weren't acting up upon the ball would continue to travel in that direction. This is shown in Newton's first law, which is an object at rest stays at rest, and an object in motion stays in motion, while the same speed and in the same direction unless acted upon by an unbalanced force. This is exactly what happens when a player shoots the basketball if there are no forces acting on the ball. It would continue to travel in the same direction, but in this situation, force acts on the ball so that it will reach its peak point, that then start traveling down. Every basketball player has to steer these forces so when they shoot, they get the ball in their hand.
Newton's laws have many impacts in daily life. Today we're looking at Newton's second law and how it applies in everyday life. Newton's second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the more force needed to accelerate that object. The equation is expressed as force equals mass times acceleration. In this case, we're looking at a basketball. When you bounce a basketball, you exert force on a ball. This force creates acceleration on the ball. If we compare this to a heavier ball, we see that there is more force exerted to generate the same acceleration. In an everyday situation, if we compare a small person running to a bigger person, the bigger person requires more force than the small person, which requires less force to match his speed.
Newton's third law states that for every action, there is an opposite or equal reaction. This means that if I were to bounce a ball on the backboard, I exert the force of the ball and the backboard creates an opposite force. This also happened in dribbling, as when I bounce the ball, I exert force on the ball and the ground and creates an opposite force. Another example in everyday application is jumping. My friend Kishara over here is going to jump to demonstrate Newton's third law. As Kishara jumps, they exert the force on the ground, as well as propelling himself up into the air.
Newton's third law also applies in the balloon rocket prac we did in science. In this prac, we looked at how different amounts of air in the balloon affected the distance the balloon travelled along the string. Newton's third law can be seen in the balloon rocket as it creates thrust which propels the balloon forward.